Okay, so just let me know once you're able to see my screen. Okay, I've shared it.
I'm able to see it.
Okay, so in the last class, we discussed complex numbers, right? We have talked about complex number. I'll give you a quick recap because this is a new thing for you. So let's talk about it. Okay, so I told you that we'll keep things simple. Complex number is any number which has two parts, right? This is the first example. Let's say we have a number z. We usually denote complex numbers with z, okay? So let's say z is a complex number. It would have two parts, 3 plus 4 iota, for example, okay? So this is the real part and this is the imaginary part. Forget about what iota is, forget about everything. Just know in complex numbers, any number would be written in this way. Okay. For example, if we have z equals iota. Now this is also a complex number, although it only has imaginary part, but we can still write it as 0 plus iota because 0 would be the real part and this is the imaginary part, right? Any questions so far?
No, ma'am, it's fine.
Okay. Just like vectors, even if you have one component, you still call it a vector, right? So this is what we have in complex numbers. Okay, now let's talk about this iota, which we also did in last class. So I told you that if we have a negative number in this under root, we can write it as -1 being multiplied with that number. And this is a property that when two numbers are being multiplied in a radical, we can write them separately and then multiply. So this is going to give you iota into under root a. Okay. Now this is the main thing, that under root -1 is iota, and let's write it this way. Iota is under root -1 and iota square is -1. Okay. So this is your go-to table whenever we talk about complex numbers. Okay. Any questions, anything which you would like to ask?
No, it's fine.
Okay, perfect. Right. Now let's talk about, okay. Now we know what complex number is. The complex number is any number which has two parts, real part and imaginary part. And don't worry about this iota. You can write it before y, you can write it after y. Okay. In some examples, in some books, you will find it before number, in some you'll find chapter number. That is mathematically correct. Okay. Don't worry about that. Okay. But now we have to see that if we have two complex numbers, how are we going to add it? So let's talk about addition first, okay? So if we have z1 is 2 plus 3 iota and z2 is 4 plus 5 iota. We have two complex numbers and we need to add them. How do we add them? We do z1 plus z2, obviously because we are adding complex numbers. Obviously, we will write them as it is this way. This is z2 and this is z1. And then just like vectors, we'll add real part and real part. This is real part, this is real part. So 2 plus 4. And then we'll add imaginary part and imaginary part. So we will have 3 iota plus 5 iota. And last step is to simplify. We'll get 6 plus 8 iota. This is the answer. So what do we know? We need to add real in real and imaginary in imaginary, and we are good with the addition, right? This is how you are going to add any complex number. Okay?
Okay.
No questions?
No.
Sure? Okay, look.
Yes.
Okay, all right. So this was the real part, this was the imaginary part, real part, imaginary part. We add real and real. 2 and 4 is 6. We add imaginary and imaginary. 3 iota and 5 iota is 8 iota, right? So this is how we add. And let's talk about subtraction. It's just like addition.
So we can just use it as do it as normal algebraic like terms and
Yeah, exactly. You can think of
okay.
it that way. Just like vectors as well. In vectors, we add you're familiar with vectors, right? At least you would be
Yes,
knowing that we have, three um
I
components,
and K.
I, J, and K. We add I and I, J and J and K and K. It's just like that, okay?
Yes.
Right. Okay. Now let's talk about subtraction. It's just the same. We don't have that much difference. Okay, so we are talking about subtraction now. Sorry, I dropped the date as well. Okay, anyways, subtraction of two numbers. Let's say we have z1 equals 7 plus 9 iota and z2 is 1 minus 2 iota. Okay, now we have two complex numbers and we want to subtract them. We want to do z1 minus z2. Okay, obviously they will tell that if it is z1 minus z2 or z2 minus z1, because we know that in subtraction order matters. Okay, but right now we're just seeing how to subtract two complex
So will
numbers.
it be 6 plus 11i?
Oh, let's check that out. Let's check that out. Okay, very good. 9 plus 7 plus 9 iota, then minus. Okay, whenever I'm teaching my students, I tell them whenever it's minus, don't try doing things directly. Although your answer
Mm.
must be correct, I'm not saying that. But when we are
Okay.
sitting for an exam, we are so much worried that in that nervousness, we end up making small mistakes.
Mm.
So these questions are very easy, and it's advisable that do try doing good number of steps, right? Okay, so minus into 1 would be minus 1, minus into minus 2 I would be plus 2i. This is going to give me 6 plus 11i. Very well done. Okay, so we are clear with this as well, right?
Yes.
Okay, so addition and subtraction was easy. Just add and subtract real and imaginary and imaginary and write down the answer. Okay, let's talk about multiplication then. Now we have multiplication of complex numbers. Okay, now let's imagine and let's keep things general now. Let's say if we have z1 equals a1 plus b1 iota and z2 is a2 plus b2 iota. Multiplication is again same. We write down, we are interested in doing z1 into z2. So what do? We write z1 first, that is a1 plus b1 iota. A1, b1, a2, b2 are any constants, right? Just so we can find out the general form, we're writing it down in a general way. Okay, this is what we get when we multiply z1 and z2.
Yes.
Okay, and now we have to do further simplification. First term into first term, like we do. Then a1 into this number, that is a1 plus a1 b2 iota. Then let's use a different color. Then b1 iota into a2. It's very simple. Okay, I'm just multiplying everything. And then this. What is it? b1 iota into b2 iota. Any questions so far?
No.
Okay, so we have a1 plus a1 b2 iota plus a2 b1 iota plus, okay, Now I can write down B1,
Shouldn't
B,
it be A1, A2?
sorry,
Shouldn't instead of A1, shouldn't it be A1, A2?
where are you, where exactly? Okay. Oh, yes, 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 here. Yes, yes, I'm sorry. Yes, you're right. You're right. Okay. When we're multiplying A1 with A2, obviously it would be A1, A2. Yes, you are right. Okay, very good. Right. And now for this term, we will have B1, B2, and iota square, right? Because we have iota and iota. We have two times iota, right? Two iotas, if we have two iotas being multiplied, what do we do in mathematics? We just write down that thing with a square, don't we?
Yes.
Okay. And this is going to give me again A1, A2 plus A1, B2 iota plus A2, B1 iota. And what is iota square?
Iota square is 1, negative
Minus.
1.
Yes, okay. So we will have plus already. We already had plus. Instead of iota square, I can write down minus 1 and then B1, B2. And yes, I can do it over here as well. Plus into minus becomes minus. So let's write it down with minus sign. So in general, I would not advise you to learn any formula for this or anything of that sort. No. You just have two numbers, two complex numbers that are being multiplied. How do we multiply things in mathematics? How do we multiply a plus b and a minus b? We do a and a, we do a and b, we do b and a, we do b and b and stuff like that. Okay. It's just that multiplication. Once you are done with this, obviously we have iota, so it would be iota square. And then there's the different part is only in last step, that since in complex numbers we have iota squared equals minus 1, so we just write down minus b1 b2. Okay, so you don't have to remember this general form. Usually students do, but I would never advise you to do that. Okay, because we will practice more questions just now and you'll see that you'll get very comfortable with it. Okay, so are you clear with this?
Yes.
Okay, then let's practice one question because it would be same. And you will see I won't be using this general form or stuff like that for that. I'll do it on my own. Okay, so let's say I have 2 plus 5 iota and 3 plus, let's say 3 iota. Okay, and now we are multiplying z1 and z2. So again, I'll write down z1 first. I'll write down z2 first. I'll write down z2 then. And then again, how do we multiply in maths? 2 into 3 is 6. 2 into 3 iota is plus 6 iota. Then we're done with 2. 5 iota into 3, 15 iota. And 5 iota into 3 iota plus 15 iota square, right? Then we write down 6.
Yes.
These are like terms, like we have iota same, we have the same. You can say it variable, although it is different. We're talking about complex numbers, but we can add them. Both are imaginary. So this is going to give you 21 iota. And then what do we get for this term?
15
Plus 15 into what is iota square?
minus 1.
Iota square is minus 1. So we write down minus 1.
So
Okay, so
minus 15.
yes, so 6 minus 15 plus 21 iota. What do we get then? Minus 9 plus 21 iota. Right? Is
Okay.
it correct?
Yes.
Okay. This is how we multiply two complex numbers. Right. So anything which you have not understood so far, any questions?
No, it's fine.
Okay, then I want you to do a question. I'll write it down. Okay, can you please multiply them? I'll give you 2 minutes. Okay, multiply and just tell me the answer.
Is it 47 plus 27i?
Okay, please check it once. Check that once, and then we can do it together.
Okay,
Did you check?
1 second.
Okay, no worries.
1 minute. Is it 42 plus 18i?
So you are getting 42 plus 18i, right?
18i.
Okay, let's check that. Okay. So how do we do? We have to multiply this number with this number. What is 6 into 7? It is 42.
42.
Then 6 into minus iota is minus 6 iota.
6 iota.
Then 3 iota with 7 would be plus 21 iota. And then 3 iota with minus iota would be minus 3
Plus 3.
iota square, right?
Yes.
Okay. So 42 plus minus 6i plus 21 is 15 iota. Okay. Is this okay?
Yes.
And then minus 3. What is iota square? It is minus 1.
Negative
Okay.
1.
Yes, it is
Yes.
negative 1. So negative 1. And finally, we have 42. Minus into minus becomes plus 3 plus 15i. So this is 45 plus 15i. This is the answer, right?
Yes.
Okay, so do you want to practice another question?
Okay.
Okay, now you have to do this again, okay? Yes, this is the question.
Minus 7 plus 22i.
Yes, very good. Excellent. Very well done. The answer is minus 7 plus 22i. Okay. So are you comfortable with multiplication now?
Yes.
And addition and subtraction was already easy, right?
Yes.
Okay. Right. Now let's talk about division of complex numbers. Okay. We have to discuss division specifically. Okay. Now, forget about division of complex numbers. Let's talk about something else. Um, are you familiar with this identity? A plus B into A minus B is A square
A
minus B
square,
square?
yeah, minus 2ab
No, 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 no.
plus
I'm doing
2ab.
no. This is A plus B into A minus B.
Oh,
Okay.
a plus b minus b. Okay.
Yes. Please write it down somewhere because it is very, very important, right? This will help you in different questions, not only in this chapter, but also some other chapters, like we have where you have to factorize and simplify things and terms, you know. So this is very important, right? So this should be on your tips that whenever you have two brackets where you have A and B, the only difference is sign difference. You get first number square minus second number square, right? If you have three, 3 plus 2 is okay. If you have, let's say, if you have 3 plus x, usually we write x plus 3. So let's write it that way. So if you have x plus 3 and if you have x minus 3, what do you get? This number square minus sign and then this number square, right? So this is what we get. And you know this already. This is an identity, right? So are you comfortable with this identity?
Yes.
Okay. Now, why are we discussing this here? I'll tell you. Let's say we have a complex number 3 plus, sorry, we have z1 equals 3 plus 4 iota and z2 is 8 minus 2 iota, and you have been asked to find z1 by z2. Okay, now in questions they are not going to use such, you know, childish or simple terms that divide z1 and z2 and stuff like that. No, it could be that there's a question in this form and they have asked you to simplify it. Okay, so obviously this thing and this thing is same, right? Is it clear?
Yes.
Okay. Now let's see how to do so. Okay. Now always remember, whenever you have a complex number and you are dividing two complex numbers, right? So obviously when you are dividing two complex numbers, you will have a complex number in denominator as well. Your goal is your goal is to get rid of this complex number in denominator. Okay, this is what you have to do. You need to get rid of this complex number. And how do we do that? You know that. Okay. So in the first class, we discussed conjugates of complex numbers. Do you remember? That let's say if z
Yes.
is a plus b iota, I told you that z conjugate would be a minus b iota. Do you remember?
Yes.
Okay. So division is very easy. We just have to multiply this fraction with the conjugate of the complex number which we have in denominator. Do you know the concept of rationalization?
Rationalizing the denominator. Yes.
Yes, very well done. So this is what we are doing, okay? And the logic is also same here. You'll see that. Okay, so what do? We multiply with a fraction of this type. What is the type? Z2 bar divided by Z2 bar. Obviously, we can only multiply a fraction that is equivalent to 1 because numerator and denominator are same. So it is mathematically correct and we have to rationalize. Okay. Now let's do it. Everything is again same. It is 3 plus 4 iota into 8 plus 2 iota divided by 8 minus 2 iota and 8 plus 2 iota. Okay. Now, do you find something over here? Can you see a minus b into a plus b over here?
Yes.
So what do we get? We get a square minus b square. Okay, so let's just write down the next step using this identity. So let's keep the numerator same for now. We'll expand that later. We know how to expand it because we know how to multiply it. We are working on division. Divided by a square, 8 is a, so 8 square minus sign, and then what is b? B is 2 iota. Okay, 2 iota. Include iota in b. Always remember, students, most of the times they just mess up here. This is b and this is a. This is again a and this is b. So we have a square minus b square. So this would be 8 square minus 2 iota square. And this is going to give you, in the denominator, we will have 8 minus 4 iota square, right? Do you agree?
Yes.
And this is going to give you 8 plus 4 because iota square is minus 1, right? Is
Yes.
that okay?
Yes.
Okay. So this is going to give me 12. I'll write down 12 here because I don't have space. I'll write 12 here and now let's multiply the numerator. Can you multiply the numerators? Because you know how to multiply now?
Yes.
Okay. Wait a second. Wait a second. You multiply the numerators and I'll write it correctly.
Okay. 16 plus 38i.
Very good. It is 16 plus 38i. Okay, so we have 8 square here. Okay, 8 square is 64. Right, and
64.
then we do 64 minus 4. That would give us 68. And in the numerator, I'll have 16 plus 38i. And this, what is this? This is z1 by z2. And now I can just separate the real and imaginary parts. 16 by 68 plus 38i by 68, and I can just cancel this thing. So we have 4 fours are 16 and 4 into 17 is 68.
That would be
And
19 by 34.
yes, very good. 19 by 34. So we get 4 by 17 plus 19 by 34 iota. Z1 by Z2. Now when we started, we had a complex number in numerator and a complex number in denominator. And in the answer, we only have one complex number, right? So remember, whenever you are dividing two complex numbers, or in short, whenever you have a complex number in denominator, you need to use the rationalization method. And what is that? You'll multiply this fraction with another fraction whose numerator and denominator is same. And what is that thing? What do we have same? We have the conjugate of this denominator. Why? Just so we can get this type of a form, right? Just so we get this type of a form, and we use this. And finally, what is the advantage of this? This iota gets squared, and when this iota is squared, we get rid of that because we use -1 instead of iota square, right? And this was our goal. In order to get rid of the complex number from denominator or iota from denominator, we multiply the conjugate of this fraction here, just so we get this type, just so we get a minus b, a plus b. That will give us a square minus b square. In b, we always have iota, never ever forget that. And now we have iota square, so we can use -1 instead of iota square. And all the other stuff is same, right? Any confusion?
No, man.
Sure.
Yes.
Okay, then let's try out another question. Can you try this question?
Yes.
Okay, I'll write down the question first and then I'll drop. This is Z2 and this is 4 minus iota divided by 1 plus 5 iota. Okay, now take your time. Okay, take your time. Don't worry about time.
Ma'am,
Yes.
is it negative 1 by 26 plus 21 by 26i?
Yes, it is the same, but it looks like there's a sign problem. But yes, it is minus 1 by 26 and 21 by 26i. Okay. Let's
And
see.
minus 21 by 26i.
Yes, minus 21 by 26i. You getting the same thing?
Yes.
Yes, very good. Excellent. Yes, your answer is correct. Okay. So you have to rationalize and just remember when you get this thing, you do a square minus b square. Never ever forget that this whole thing is your b. Okay. This is your b. And then if when you square b, you get minus 25, right? Because you get 5 square and iota square, that is 25 and minus 1. Okay. Any questions?
No.
So are you 100% clear with this topic?
Yes.
Okay, so you know addition, subtraction, multiplication, and division of complex numbers. Right. So the next topic is 9.3. Now we have the third section of your book, that is 9.3. Complex roots of polynomial equations. Right. So, so far, before this chapter, whenever you used to solve quadratic equations and you used to get under root minus something, let's say a, we write no real solution, right? So this is correct. This is not a real solution, it is a complex solution. It is a complex root, right? So whenever we are solving a quadratic equation, let's say we have x square plus 2x minus 3, for example, or maybe plus 3 equals 0. We solve it whatever way we do, and if you get under root minus something, let's say you get under root minus 2, for example, I'm just giving you an example, obviously you will not get this. So you used to write no real solution. So this is not a real solution, this is a complex solution. Why? Because we know that under root minus 2 can be written as under root minus 1 into 2, and that is under root minus 1 into under root 2, and this under root minus 1 is iota under root 2, right?
Yes.
Okay. So we know this, that when a solution is not real, it is complex. Okay. Okay, and are you familiar with factor theorem and remainder theorem and things like those?
Yes.
Okay, that's
Yes.
really good. Okay, so we can talk about an example directly. Let's say we have a polynomial p of x equals x cube minus x square plus x minus 1, and we are interested in factorizing it or finding its factor. Okay, whatever you can call it anything, but we are interested in finding out the factors. So what do? The first factor is we find that by a hit and trial method. So we think of a number. Let's say, what do you
1.
think? Yes, very good. So we use x equals 1, and let's see if x equals 1 give us p of 1, 0. This would be 1
It will
cube.
give 0.
Yes, it will give 0. Plus 1 and minus 1, and this is 0. So what does this imply? Since x equals 1 is giving you 0, so
X minus 1 will be a factor of.
very well done. Okay, x minus 1 is a factor. Okay, and now we are interested in finding out the other factors. Okay, now how can we do that? Okay, now for finding out the other factors, we can use the long division method. We write the polynomial here, x cube minus x square plus x minus. Do you know this long division method?
Yes.
Okay, that's amazing. Right. Now we have to multiply x square, right? Just so we get x cube here, right?
Cube.
This number is x cube. We need to multiply this x with such a number that we get x cube here. So obviously that number is going to be x square, right? Yes, Ranjani?
Yes.
Okay. So we multiply x square with x, we get x cube. Then we multiply x square with minus 1, we get minus x square. Okay, and then we minus this thing, so we will get 0 plus x minus 1. Now, obviously, we need to get x. We already have x. So we write plus. Yes, what do we write? Plus 1.
Yeah, plus 1.
So that is going to give you x minus 1 again. And this will be 0. So how am I writing things
0.
there? I'll tell you this as well. Okay, so this is my dividend and this was the factor. And in this case, it is the divisor, right? The rule is that this number is x cube, okay? If this number is x cube, you want x cube here. How will you get x cube here? By multiplying x square with x, okay? By multiplying x square with x. You just need to follow this number. Just follow this number. You want x cube here, so you will multiply x square with x, and this is why I've written x square, right? Now you have x minus 1, so you follow this number, and here you have x already, so you only multiply with 1, because when you multiply it with 1, you'll get x directly, and because we are subtracting this, so we will get 0. So what is the factor which we are getting? We are getting x square plus 1 is a
The other
factor.
factor.
Yeah, is the other factor. Okay, and what is the root? We are talking about root. So x square plus 1 equals 0 is the root. This implies x square equals minus 1. This implies x equals plus minus
Plus minus 1.
under root minus 1.
Which is I.
Yes, x, very good. X plus minus I. Right? This is what we are getting. So are you clear with this?
Yes.
Okay. Are you clear with the long division as well? You can ask me this as well.
Yes. It's
Okay.
fine.
All right. So this is how we find complex roots. Okay. Now the new thing is, which I would like to tell you before going to the next example, that whenever your obviously you can have real roots, you can have complex roots, like this was a real root, and then these are your complex roots. You will always get complex roots as a pair. Okay, let's say if x equals I is your complex root, you'll get the conjugate of this as another complex root, right? Just in this case, we got plus minus iota. So whenever you are finding out the roots of any polynomial and you calculate, or they mention that this is a root, and that is a complex number. So you can always guess, you can always say that conjugate of that complex number would also be the root. Okay, so you'll get a better understanding once we do this example.
Okay.
Let's say we have another question. Z equals -2 plus iota is a root of z cube plus z square minus 7z minus 15 equals 0. Find the other roots. Okay, now this is the question. They're saying that this is your polynomial, and they have told you that z equals -2 plus iota is a root. Okay, so
So you just have to divide the two.
okay, now I'll tell you. What are you saying? You will just divide the two?
Yes, you will divide minus 2 plus iota with the polynomial.
Okay, now okay, your like your thinking is right, and anyone would have said that. Very good. But think about this. You have just seen how to divide a complex number, right? And you know that dividing a complex number is not that easy. You'll get a big expression and you would not be able to simplify it. So we do this type of these type of questions this way. If z1 or if z equals -2 plus iota is a root, it is given that the conjugate of this root, what is the conjugate of this complex number?
Minus 2 minus I.
Excellent. It is given that if this is a root, the conjugate of this complex number would also be a root, right? There's no doubt in this. Okay?
Yeah.
Okay. Now, if these two are roots, what is the corresponding factor? When like we say x equals a is a root, so we say that x minus a would be a factor. So what would be the factor? The factor would be z minus -2 plus iota, just like our previous knowledge, right? This is going to be a factor, isn't it?
Yes.
What do we do? Z minus and the root. And the other one is again z minus and the root. Okay, right. So we got two roots already, and we are interested in finding out the last one now. So for that, let's multiply these two numbers, these two factors, and then we can divide the answer with the polynomial. Why? You'll get to know that once we divide these two factors, because you will see that things would be much easier after multiplication. Okay, so we need to multiply these two, right? So this means that we have z minus into -2 becomes +2, minus into plus iota becomes minus iota. This is the first factor, and then for the second factor we have z minus into minus is +2, minus into minus iota is plus iota, right? Is this clear?
Yes.
Okay. Now you have to multiply Okay, now again, it is your choice. Okay, either you can multiply this way, that you do z into z, then z into 2, and then z into I, and then for 2 you have to do the same steps and all that. Or you can think of it differently. Do you see a minus b and a plus b form here? If you think of this
Yes.
as a and think of this as b, think of this as a and think of this as b, you can write z plus 2 square minus iota square. Okay, and if we simplify this, what do we get? Z square plus 2 into 2 z plus 2 square, that is 4, minus into iota square is minus 1. So what do you get? Z square plus 4z plus 5. Any questions so far?
Can you explain uh, the first part? You take the conjugate and then
Okay, I'll tell you again. Okay. Now this is a different type of question. Okay. In the previous question, we had to find root. So that was simple. We just did long division. We got our factor. We said that that factor equals 0 and we got our. Okay. In this question, the statement is different. They are telling you that this is a root. Okay. And in the last part of the first example, in the last part of the previous example, I told you that whenever you have z equals iota as your root, it is certain that z equals minus iota would also be your root. Okay, and you got plus minus iota in the last part because the conjugate of this complex number is this complex number, right? So you could see that in the
yes,
last part as well, that whenever you have a complex root, it is not alone. It comes in pair every time. Okay, you write pair of two complex numbers whenever you have been told that one is root. So in this example, we are told that this is a root. So as soon as you read this statement, immediately you should think of this as the second root, because whenever you have complex roots, you know that they come in pair. So if z is a root, z conjugate would also be a root, right? Are you clear so far?
yes,
Okay. Now, in previous questions, what we used to do is, if we have, let's say, x equals minus 2 plus iota, we used to write down the factor, that is z minus and then this whole thing. And then we used to, follow the long division method and find out the third factor. But don't you think with iota that is going to be very complicated, right?
yes,
So what do we do? Whenever we have a complex root, we find out the other complex root, that is the complex of this complex root, right? And once we have both complex roots, we find out the corresponding factors. Okay, these would be the factors: z minus first root and z minus second root, and then we multiply it. And once we multiply it, look, things have become so simple. Now this again is without iota. Now you can do the same thing. Now you can do the same thing. Okay. Now you can do the division, long division, and find out the third root, but not before that. Okay, not before that. Are you clear?
yes,
So in short, either they'll give you a real root. If they give you a real root, you're good to go. You can find the complex root through long division directly, because in the quotient, you will get a factor of this type, let's say x square plus 4, and you then equate it to 0, and then you get x square equals, you know, minus 4, right? Stuff like that. And then you end up saying
yes,
x equals plus minus 2 iota. Yes, that is clear. But whenever they have given you one complex root and they want you to find out the other roots, you cannot find out your factor through this and do long division. No, you have iota, you cannot do it this way. Things would be very, very complicated. So the rule is, if this is a root, its complex would, or its conjugate would also be a root. So what is the conjugate of -2 plus iota? You said very well. This would be the conjugate and this would be the other root. Now you can always find out the corresponding factors, and you are multiplying two factors. Obviously, when you multiply two factors, this yellow box, the stuff written in this yellow box is also a factor, right?
Yes.
Let's say you have a polynomial ax cube plus bx square plus c x plus t, and you find out the factors. So you get x minus a1, x minus a2, and x minus a3, right? So obviously x minus a1 into x minus a2, this is also a factor, right? You can always multiply these two. This is also a factor, right? Are you understanding this?
Yes.
Are you sure?
Yes.
Okay. Do you remember such questions when you used to have a cubic polynomial and you were given with a factor of this type? Let's say x minus 2. How do we solve such questions? We just write it as our divisor. We write this polynomial in the dividend. And obviously, when we have a cubic polynomial and a linear factor has been given, it's obvious that we get a quadratic quotient, right? And then in the very end, we used to write down this quadratic. Let's say it's this quadratic factor into two linear factors, right? Do you remember
Yes.
all that? Okay. X
Yes.
minus a and x minus b. So you know this, that when we multiply these two, obviously this is also a factor. You can think of it as a big factor, right? And out of this big factor, you're getting these two small factors. So here you have two factors. You can always multiply them. And why are we multiplying them? Because initially we have things in iota, but as soon as we'll multiply it, we will get rid of the iota and we will get z only. And now we can think of it as a big factor and do long division to find out the other factor. Okay, let's do the long division then. Are you okay with this?
Yes.
Okay. So what is the polynomial? Can you tell me the polynomial?
Z cube plus
Very
Z
good.
square
Yes, and
minus 7Z minus 15.
very good. Okay. And what is the factor which we got?
Factor
Yes, the
Z square plus 4Z plus 5.
z square plus 4z plus 5. Very good. Okay. Now, what number am I going to multiply first in order to get this z cube? What is going to come here?
Z square.
Very good. Z square, z only. Okay, only z.
Yeah. Oh, yeah. Sorry. Only Z.
Okay, so we will get z cube
Z
plus
cube
4z square plus 5z. That's it. We write it this way because we have to subtract it. So for z cube minus z cube would be 0. Z square minus 4z square is minus 3z square. Minus 7z minus 5z is minus 12z. And minus 15 is going to come here as it is. Now what do I multiply with z square to get minus 3z square?
3. Minus 3.
Minus 3. Excellent. So I multiply minus 3 and I'm going to get minus 3z square. Minus 3 into 4z is minus 12z. And minus 3 into 5 is minus 15. And I am going to get 0. So this implies z minus 3 is the last factor, right? So what is the corresponding root? If z minus 3 is a factor, z equals 3. And z equals 3 is a real root, right? So this is how
Yes.
we work with complex roots of polynomial equations. Are you clear with this?
Yes.
Any doubt, anything, please have a look at it and let me know if you're not able to understand it, okay?
Okay.
Yes, are you clear with this?
Yes.
Sure, Anjani, no questions?
Yes.
Okay.
No. Can we do one more question? Similar kind.
Okay, all right. Let me take out a question then. Okay, so let's say that all right, so let's say if the polynomial is p of x equals x cube minus 10 x square plus 34x minus 40. This is your polynomial and you have been told that z equals 3 minus iota is a root. Okay. Now, how do we find the other roots? So the question is find the other roots. Okay. So let's solve it together. Now you have been told that z equals 3 minus iota is a root, right? Z equals 3 minus iota is a root. As soon as you read this, what do you understand? That what else are you going to have as your root?
3 plus I.
Very good. Okay. 3 plus I, because conjugate of this z would also be a root, right? So we are clear with this. Okay. Now what is the next step? We need to write down the factors. So we get z minus the first root, and we get z minus the second root. Okay, and then this would be z minus 3 plus iota. Minus 3 minus 1 into 3 is minus 1, and minus into minus iota is plus iota, right? Is it clear so far?
Yes.
And then we have z minus into 3 is minus 3, and minus into iota is minus iota. Okay, now
Iota.
again, what is the next step? Yes, what do you see? Do you see a plus b and a minus b?
A plus B.
If this is
Yes.
a,
3 plus I and 3 minus I.
3, what? No, z, you have to think of this whole thing now. Z minus 3 is a, okay? Z minus 3 is a, and I is b, okay?
Okay.
Right? Because we
Yes.
have z here as well. So you need to think this way. Okay, now what do we get? We get a square minus b square. What is a?
Z minus 3.
Z minus 3. And what is b?
I.
Very good. Okay, so z minus 3 square will give me z square minus 2 into 3 into z plus 3 square, that is 9, and then minus, what is iota square?
-1.
So this would become
+1.
very good. And finally we have z square minus 6z plus 10. Okay, now this is the factor which you need to divide by this polynomial, right, to get the third root. Clear?
Yes.
Sure?
Yes.
Okay, so let's just write down. I need to rub this. Maybe I can try doing it here. No, but that would become very complicated, so maybe I can rub it. So we got z square minus 6z plus 10 as a factor. Okay. And now, obviously, this is in x because this is p of x. In order to divide it, we need to write it as p of z, right? I hope that is not an issue.
No, it's fine.
Okay. Right. So now we have z square here and we have z cube here. What number should I use? Yes, what should I write down here?
Z. Z.
Z.
The Z.
Very good. So that would give me z cube minus 6z square plus 10z. This would be subtracted. So this is going to give me z cube minus z cube is 0. Minus 10z square plus 6z square would be minus 4z square,
4. Yes.
and plus 34z minus
4.
10z plus 24z, and then minus 40 will come as it is. Okay. And now
Minus 4.
minus 4. So this will give me minus 4z square plus 24z minus 40. This is 0. So this implies z minus 4 is a factor, right?
Yes.
So are you clear now?
Yes.
Any questions? Anything which you are not clear with?
No, it's fine.
Sure, just look at it once more and then let me know.
It's fine. It's fine.
Okay, perfect. So we should talk about the fourth section. So the fourth section is are you familiar with cylindrical coordinates and all that? With polar coordinates, cylindrical coordinates?
No.
No, okay, that's okay. It is again very easy. Don't think of it as something complicated. And the fourth section is polar form of a complex number. Okay, now before studying this section, I would like to ask you what form have we studied so far? In simple words, can you tell me the form which we have been discussing of a complex number? Like, how do we write a complex number? If z is a complex number, we
A
write
real number. A real
yes,
number plus an imaginary
imaginary
number.
part. Excellent, very well done. Okay, so this is the form which we have been using, and this is called the rectangular form of a complex number. Just like you must be familiar with Cartesian form and all that, when we write xy, we call it Cartesian form. And then we have, polar coordinates and all that. So it is a form, okay? We call it rectangular form. Okay, now we don't have to discuss this form. I can write down the same number, the same z equals x plus iota y in an equivalent form, that is z equals r cos theta plus iota sin theta. Okay, now this is the polar form. Okay, it's very easy, trust me. So you are comfortable with rectangular form, okay? And I'm telling you that polar form and rectangular form are equivalent, okay? If I write down a number in rectangular form or I write down a number in polar form, they are equal. And you will see that how we will go from rectangular to polar form. Okay, are you clear with the forms that we have two forms? In one form we have x plus iota y. We write down real plus imaginary part, and over here we are writing it this way. We have r cos theta plus iota sin theta. Okay, and even here you can write it this way as r cos theta plus iota r sine theta. So again, you can say that you have a real part and you have a complex part, but this time around you have a radius and you have a theta. But in the rectangular form, you don't have such things. Are you clear with this?
Yes.
Okay. Now, without rubbing this, I will explain this on through a diagram. Let's say this is a graph. This is the real axis and this is the imaginary axis. Okay, now let's say we have a number z equals x plus iota y. So let's just think that this is x and this is y. And if I'm interested in pointing this, in plotting this complex number, it would be somewhere here, right? The x coordinate is x and the y coordinate is y. And I can draw a line connecting the origin at this point, right? So this is how I can represent z equals x plus iota y. Okay, any questions so far? Anything that you have not understood?
Uh,
Okay, wait, I'll tell you.
no, it's fine, I think.
Sorry?
I think it's fine.
Okay, think of it this way. Just like this is a graph where you have 1, 2, where you have 1, 2, and you are interested in plotting 2, 1. How do you plot 2, 1? You go to x equals 2, this is x and this is y, and you go to y equals 1.
One.
So
Yes.
this is how you plot, right? And in complex numbers, we just connect the origin with this point. And this line is basically
Y
a
equals X.
representation of this, okay? This complex number. Right. So this is the rectangular form. We'll see how we will create the polar form using the same diagram. So I can make a yellow line over here, and this is my theta, and this distance right here is my r. So obviously this length is x and this length is y. And now can you find these theta and r by thinking of
Yes.
it as a right angle triangle?
Yes, you can.
So what is the value of r? R would be, use Pythagoras theorem.
R is the hypotenuse. So,
Yes, yes, yes. So it would be,
but you don't know the values of Y and X, right?
yes. So I want you to tell me in terms of x and y.
Sine Y over
No, 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 no,
X.
no. No, wait, 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 wait.
Wait,
I want you to use the Pythagoras theorem. So how do we do? Square of longest side,
Y
that,
square. Yeah, okay, fine. Y square plus X square equals R square.
very well done, okay? And I can write it as r equals under root x
Y
square
square plus
plus
X
y
square.
square. And in the first class, do you remember that modulus function which we talked about?
Yes.
So what was that? That was the same thing, right? We square the real part and imaginary part. So r is basically z mod. R is z mod. R is Z mod, okay? And even if you have forgotten Z mod, now you can remember that Z mod and R are under root of real part and imaginary part, okay? I repeat, you would have your rectangular form which has X and Y. And now you are interested in finding out the polar form, okay? So this is your polar form. What do you have in your polar form? You have R, you have theta. You have R, you have theta. If you find this R using X and Y, and if you find the theta using X and Y, things would be very easy. You would be able to go from rectangular form to polar form, right? So far, we have just discussed how to find this R. Forget about this theta, we'll do that in next class. But are you clear till now
Yes.
that, and even if you have not understood it this way, this is going to be the formula every time, okay? This is a rule that you have. Obviously, when they will give you rectangular form, you will be having the values of X and Y, won't you? And you can easily find under root X square plus Y square. But remember, Anjali, this is Y square. This time you will not write iota y square, okay? You only have to square the number which is written with y. For example, let's say z is 2 plus iota, or maybe 2 plus 2 iota. Let's keep it this way. So r would be under root x square plus y square. What is x?
X will be
This, right?
that's
X is 2 square, and
yeah, okay. 2 square plus 2i square.
exactly, this is what I'm telling you. We have y square here, okay? We have y square here. And what is y? This is y, the number which we write with iota. You don't write iota here. You'll only write 2 here, okay? Right?
Yes.
Okay, so we will have under root 8. So this is how we will find r every time. If you have not understood it this way, you should just know that you will be having your rectangular form. From your rectangular form, you need to write down x and y. For example, if z is 4 plus 8 iota, what is x? Compare these two. What is x?
2.
X is 4.
Yes, X
This
is
is 4.
4 and Y is 8i.
No. What is y, Ranjani?
Just
Compare,
8?
yes, compare these two, okay? We have iota y and we have 8 iota. So the number which is written with iota is y, okay? The number which is written with iota is y. Just like we, in partial fractions, we make comparison and find out the value of, a, b and all those coefficients. Similarly, you're making comparison. So iota is with y. So this means that 8 is y only, okay? It is 8. And now once you have x and y, you only have to do x square plus y square. And you can easily find under root 16 plus 64. So is this clear now?
Yes.
Sure?
Yes.
Okay, for example, if your z is 8 plus 2i, can you please find out the r?
So X will be 8 and Y will be 2.
Very good. So that would be
So it will be 8 square plus 2 square, which is 68.
very good. So under root 68 would be r, right? Always
Yes.
remember, don't think that in some places we are writing iota with square and in some places we are not. No. we are talking about maths. We're talking about logic. Okay, if you have been told that this is your z, and if you have been told that this is the polar form where you have r, and in order to find this r you have to do x square plus y square. What is y square? What is y? Y is the number which is written with iota. Iota is not included. Okay, it is iota y. Only think about this y. Forget about iota because we have y only. We are not writing iota y whole square. We are writing y square. What is y? Y is the number which is written with iota in your complex number, particularly in the imaginary part. It is the number, not iota. Are you clear?
Yes.
So this is how we find r.
The imaginary part is already labeled, that's why, right?
Yes, imaginary part is, sorry, imaginary part is the part with iota basically.
Okay.
This is the real part and this is the imaginary part, right?
Yes.
Are
And
you,
what about R?
what do you mean, what about r?
We're finding X, Y, and R is the imaginary part. I don't get what the Y equals X that.
R is a real number. R is a real number.
Oh,
Yes,
okay.
R is the real number. Okay.
R and R equals modulus of Z. That means
Yes. In the first class, I told you how to find Z mod, right? So if you have Z equals X plus iota y, this is how you find z mod as well. Okay, under root x square plus y
yes,
square. It's
Y
okay,
square.
we will discuss this whole thing in the next class, don't worry. Okay, you'll get a better idea, but
Okay.
for now just revise multiplication, subtraction, addition, and division of complex numbers, and the complex roots of a polynomial, right? Whatever we have discussed today other than the last section. Okay.